Starts with a body of water, because a lot of times fossils are found in bodies of water. And fossils can only be found in sedimentary rocks. Because when we think about magma, when we think about hot, burning rock, what if a plant or a little bug or a little mouse fell into lava? Would that leave an imprint on the rock, or would it just basically get burned up and destroyed in there? Get burned up and destroyed. So fossils are found in sedimentary rocks. So if you go to Hawaii and they're trying to sell you fossils from Hawaii, they're being dishonest. Because we can't have fossils in lava. It's just too harsh. Okay? So in order to have fossils, we have to have animals or plants that are quickly buried in sediments. Need to be quickly buried in sediments. So something dies, all of a sudden it's at the end where it's at the point where a river empties into an ocean, and those sediments just bury it. What happens to most animals when they die, say on a beach or out in the woods or whatever? What happens to dead animals? Why aren't there dead animals laying all over the place? They decay, and they also get eaten and ripped apart by other animals like hyenas or other predators or scavengers, right? So fossils, in order to form, they need to be quickly buried, and they have to have some hard parts like skeletons and bones and things like that. Okay. Now, let's say in this sea we've got a bunch of fish living, and eventually fish, people, plants, everything eventually will die, right? So when fish die, they initially float to the top because the bacteria that's eating their flesh gives off gases, but they will also at some point sink to the bottom. So we've got these fish here that die, and if a bunch of sediments now falls on to this bottom of the lake from a river that's carrying sediments and it empties it into the lake, eventually they may be covered up and they may become fossils. Okay? Has to be very certain conditions in order for fossils to form. Quickly buried, hard parts, there has to be enough sediment and so on. Now, other fish live in this ocean, and let's say, a couple hundred or 1,000 or 2,000 or 10,000 years later, there's some other fish living, and those two aren't eaten, those two die, and they are also buried, and through lithification or cementation, they're hardened, and so now we have another layer of these dead fish. And let's say there were some crabs, and I can't draw, okay, there's some crabs in there, and they also die, and they're buried. And so when paleontologists or scientists come, and let's say this whole lake dries up, and they come and start digging, what layer are they going to find first? The top layer. And this layer would be younger or older than this layer? Younger. Okay? And then this layer would be the next, and then this layer would be the next. So we can tell how old fossils are by what layer they came out of the earth. Did they come out of the top layer, the second layer, the third layer? The Grand Canyon has hundreds of layers. Through time, a nice geologic record of everything that's happened in that area. And there's fossils all over the place. And so they know that the ones on top are younger than the ones on the bottom. This is called the law of superposition. So we know the ones on top are younger than the ones at the bottom. So, you can start.
So we can all look at them.
Oh, okay. You want to look at them and see if they match first. Okay, that's great.
You're just comparing how they look different between the two areas. You get what I'm saying? So like you compare
kind of
two
when you
from
compare,
here, two from there.
okay, so you kind of compare like R1 and Z1,
Yeah.
right? Okay.
So you've got the S's in order and the W's in order. Yeah, some of them are, I don't know. What I want you to do at your table is tell me which one is the youngest and which one is the oldest. You need to be able to relate them to one another in such a way that you will be able to tell me which one's the youngest, which one's the oldest.
So are we doing the oldest to youngest just with the V's and then like doing each letter? Or are we doing it all?
So you're going to just arrange them, okay? So now you've got the V's done. Does anything in one of these match any of your other ones?
Okay.
If it does, put that one exactly next to the one that exactly matches it, and then work on that row, okay? So let's see how you guys did. All right, so you guys have,
And 1 is being the newest,
okay,
and then V3 being the oldest.
okay, excellent. Okay, so are you ready for the next thing?
So we started with one bag and we found other bags that matched the fossil and we lined them up next to each other and we just kept going until we finished.
Excellent. That's called correlations. And this seems like an index fossil in that it's found in lots of different places. So it kind of helped you organize everything. Put the rest of the G's. Where are you going to put G1? Are there any other G's? What's your very oldest fossil?
V3.
V3. What's your very youngest fossil?
M1.
M1. Okay, you see that? So, so these are what we call correlations. Okay? So B5 and C2 are a correlation. They're exact matches, right? B5 and C2. And then C5 and A3 are exact matches. Okay? Does that make sense? Youngest. Which ones are the youngest?
That's what we're kind of
Good.
confused on.
T1 and W1 you can't really say because they're both at the same level. Okay? And which ones are the youngest? I mean the oldest.
This one would be like older than that one.
Okay, so S3 would be the oldest.
I almost was here too.
I mean, it's just,
So sick and stuff.
but you're going to get this on the exam.
Yep.
And then,
Then C1 is all the way up here, right?
What you would put is like, we started with the B, so you put the B down, and then you know this one matches with this one,
And so then
you would
this one
start
will
with C
shift
and
all
you
the way up.
put the
four will be on the exam. So if I asked you what's older, the sandstone or the conglomerate, okay, which one is older, the sandstone or the conglomerate? The sandstone. Which one is older, the shale or the conglomerate? The conglomerate. So in one case this was younger, in another case it's older. It just depends what you're comparing it to, right? So figure 11.4. This exact figure will be on the exam. Now, these things have to do with this cross-cutting relationships.